Okay, and we will start from exercise number 4. Exercise number 4. Exercise number 4 from electricity and magnetism. Electricity and magnetism. A ring is made from thin wire and has radius r. But I will write big letter R because it is more convenient in this case. A ring is made of thin wire and has radius r and charge q. And charge q. And charge q. Find the modulus of electric field intensity on the axis of the ring as function of the distance L. As function of the distance L to the center of the ring. Investigate obtain dependence when L is much bigger than R. Define the maximal value of the electric field intensity and corresponding distance L. Okay, I think it is necessary to draw a picture. To draw a picture. So let's do this. Let's do this. Ring with the charge q. This is a ring. And I think it is necessary to draw some axis. This is axis x. X. This is z. And this one is y. And this one is y. Axis y. Okay, and the radius of this ring is equal to r. Radius is equal to r. Radius is equal to r. Okay, and the distance from the beginning of the from the center of the ring to the point where we want to find electric field intensity is equal to L. Is equal to L according to the condition of the exercise. According to the condition of the exercise. Okay. Okay. So, do you have any ideas? Do you have any ideas how to solve this exercise? I remind that we want to find electric field intensity. Electric field intensity here on axis of this ring. We have to find electric field intensity. Maybe you have some ideas. Maybe you have some ideas how to do this. no ideas. Okay, I think we have the only one thing to do. The only one thing to do is to use a formula for electric field intensity of point charge. And I will use a formula for modulus of electric field intensity vector. But I will use this to an infinitely small element of the ring. I will use this for infinitely small element of the ring, 4p epsilon 0, 4p epsilon 0, absolute value of differential of electric charge, and this is divided by r to the power of 2. Okay, and what is dq? dq is infinitely small charge. It is infinitely small charge. It can be shown here. So I will define infinitely small part of this ring, and charge of it will be dq. It will be dq, and the distance from dq to axis to definite point on axis x. This distance is equal to r. This is r. This is r. And this is radius of the ring. Okay. Okay. The next question is how to define this value r. How to define this according to the geometry of this system. So the question is how to define this value. Who can tell this? Who can tell this? How to define R? Okay, it seems that we have the right triangle. If I draw it separately, it will look something like this. It will look something like this if I draw it separately. So it will be something like this. The right triangle. So we have R. We have L, the right angle, and here we have R. little r. Okay, how to find this value r? I think it is very simple question, and
R power 2, L power 2 equal to the like R in R square is hypotenuse, something like that name it. Do you understand?
yes, you can write this. You can write this on the screen. Yes, this is correct. This is correct. Thank you. Yes, according to the Pythagore theorem. According to the Pythagore theorem. Yes, it is equal to square root. R is equal to square root from r to the power of 2 plus L to the power of 2. Okay, that's good idea. That's good idea. So we will use this. So it will be L to the power of 2 plus R to the power of 2 to the power of 2. Okay, this is good idea. This is good idea. This is good idea, and so we have this distance. This distance that is signed with little letter r. Okay, so I can write that this is equal 1 divided by 4p epsilon 0, and then absolute value of dq, absolute value of dq, and the square root of L to the power of 2 plus R to the power of 2. Okay, and to the power of 2. Hey, do you have any questions about this? No questions. No questions. Okay, if there are no questions, uh, let's continue. Let's continue. But it is necessary to remove this vector above the E, above electric field intensity. Okay, so electric field intensity vector that is produced by charge dq, that is produced by charge dq. It can be drawn like this. It can be drawn in this way. So this is vector dE. This is vector dE. This is vector dE. And we have found it. We have found its modulus, its absolute value of vector dE. But we need to find vector E from here. We need to find vector E. And how to do this? How to find vector E, or for example, its modulus? It is necessary to say that we cannot just integrate. We cannot do this. We cannot do this. Why? Because we have vector values. We have vector values. It means that if we have two vectors, for example, if we have that vector C is equal to vector A plus vector B, but it doesn't mean that C is equal to A plus. So we cannot make this conclusion. It doesn't mean this. It doesn't mean this. Why? Because vectors A and B may have different directions. These vectors may have different directions. So what can we do in this situation? What can we do in this situation? In this situation, it is necessary to use vector sum. It is necessary to use vector sum. So we can write that this is equal to the integral dE, but as a vector. So it can be written as integral of dE x. I will write this in projections plus dE y j and plus d e z k. D e z k. Okay, and this will be equal. This will be equal to. This will be equal. It can be if you write this in such way. It can be written. No, it can be written in this way. So I'll write this in next way. So and integral of this and integral of this. Okay, so we have such relation. We have such relation, and to find electric field intensity, we have to find these three integrals. But what can we say? About these two integrals? Maybe we can find them immediately. Maybe we can find them immediately. What do you think about them? According to the symmetry of this system. according to the symmetry of this system. What can we decide about these two integrals? Of course, they can be calculated. These integrals can be calculated, but we don't need to do this. We don't have to do this because we can define them immediately. Okay, maybe I will have a look at this picture. At this picture, according to the symmetry, we have charge dq here, but we will have the same charge on the other side of the ring. We have the same charge here. And what does it mean? It means that if I rewrite this separately, I have dq and dq, and here I have axis x between them, horizontal axis x. This is horizontal axis, and according to this picture, upper charge will produce field with intensity for example dE, for intensity dE, and lower charge will produce field with intensity for example it will be dE1 and it will be dE2, because these vectors have the same absolute values, but different directions. Okay, and according to this picture, I can use this rule of adding this rule to add vectors. So according to this picture, the vector sum of this vector will be directed along the x-axis. So here we have dE1 plus dE2. So vector sum will be directed along the x-axis. It means that there are no y component and z component. So according to this picture, we have that these two integrals are equal to 0. They are equal to 0. It derives from this picture. That this is equal to 0. So we only need to find the first integral. We only need to find the first integral here. Okay, do you have any questions about this? no questions. If there are no questions, I will remove this picture because we don't need this anymore. And I will remove this. I will remove this. So we have that this is equal to integral d e x dex I. So we have the only one projection of vector. Okay, and according to this, because we have to, according to the condition, we have to find the absolute value of vector e. So we will have e is equal to modulus of absolute value of vector e, and it will be modulus of this. Will be modulus of this, and it will be just integral of d e x dex. Okay, and we can so we can also write integral limits from 0 to e. Okay, so the next step we have to do is to find dex. And how to do this? How to find dex? Does anyone know how to do this? I remind that we have already found de. We have already found this, but now we have to find its projection on x-axis dex. We have to find dex. Okay, maybe it can be done. It can be done from this picture. From this picture, I will draw this. I will draw this in bigger view. I will draw this in bigger view. So we will have for example, we will have x-axis. We will have x-axis, x, and here we have de. Here we have de. de. And what is dex? What is dex? Dex is a projection of de on axis x. So I have to draw a perpendicular, and this projection will be here. So this is This is DEX. Okay. This is DEX. Here we have the right angle. Here we have the right angle. Okay, this is DEX. Okay, so how can we find DEX from this triangle? Okay, but if we also have the angle beta here, if we also have the angle beta, okay, let's simplify this situation. Let's I will draw this in another way. Okay, if we for example, if we have the triangle, and here A, B, not B, for example, we have yes, we don't have this okay, we have C, and we have beta, and we have beta. But if we want to find A, how to do this according to this picture? Who knows how to do this? So we have hypotenuse C. We have this angle beta, but it is necessary to find this side A. And it can be done. It can be done according to geometry. It will be equal to C cosine beta. C cosine beta. C cosine beta. And here we have the same situation. Here we have the same situation. So DEX is equal to DE is equal to DE multiplied by cosine beta. Multiplied by cosine beta. Okay, is it clear or not? Maybe if you have, maybe you have some questions about this. No questions. No questions. Okay, if there are no questions, I will remove unnecessary pictures. We already don't need them. We don't need them anymore. So I will remove them. So DEX projection is equal to dE multiplied by cosine beta. And on this picture, we have beta here. This is beta, and of course, it will be beta either. So here we have beta 2. Okay, and according to this, beta angle is here. Beta is here. Okay, and how to find cosine beta from this picture? How to find cosine beta? From this picture. Does someone remember how to find cosine from the right triangle? If we know all its sides of this triangle. Nobody knows. Nobody knows. Okay. Okay, we can. It is a well-known thing. It will be L. It will be L divided by R. Divided by R, and of course it will be L. It will be L divided by square root of L to the power of 2 plus R to the power of 2. Plus R to the power of 2. Plus R to the power of 2. Okay, do you have any questions about this? No questions. No questions. Okay, so if there are no questions, I will remove this picture because we don't need this anymore. And okay, so it is necessary to, and I will remove this. If there are no questions, I will remove this from the screen, and maybe it is necessary to okay, let's find this DEX. Let's find this value DEX. Let's find this projection. Now, according to these two formula, we have that it is equal to 1 divided by 4 pi epsilon 0. 1 divided by 4 pi epsilon 0, and multiplied by L divided by this square root. Okay. Okay, and what do we have here? We can we can a little bit simplify this. So it will be 1 divided by 4p epsilon 0, 4p epsilon 0, 4p epsilon 0, L, absolute value of dq, absolute value of dq, divided by square root of L to the power of 2 plus R to the power of 2, and it will be to the power of square root will be to the power of 3. Okay, and it means that we will have integral. We will have integral that looks like this. Okay, and the next step is to define integral limits. What will be integral limits here? Okay, according to the condition, the charge of the ring is Q. The charge of the ring is Q. So if we add all parts of this charge, if we add all dq, if we find sum of them, if we find their sum, we will obtain absolute value. We will obtain absolute value of dq. So from 0 to dq. From 0 to dq. Вот. From 0 to dq. And L and R and P and epsilon 0 don't depend on dq. So I can write them outside the integral. Outside the integral. I can write this, but without L. And here we have integral from 0 to absolute value of dq. Sorry, I have made a mistake. L. Of course, here we have L. Absolute value of dq. Okay, and do you remember how to calculate such an integral? And do you remember what to do with this? Don't remember. Okay, but we have already done this a few times. So I think I think it is not a so difficult question. So we will obtain the value or the absolute value of electric field intensity on the axis of the ring as a dependence on distance to its center. Okay, do you have any questions about this? Do you have any questions? No questions. No questions. If you don't have any questions, I will remove some unnecessary things. I will remove some unnecessary things and uh, I I will just leave the answer and the picture. So in this situation, we have absolute value of electric field intensity. Absolute value of electric field intensity. It is written here. Absolute value of electric field intensity. But what to do? What to do if we have, according to the condition, what to do if what to do if what to do if L is much bigger, is much larger than R? What to do in this situation? What to do in this case? Okay, in this case, we'll have we will have we will have that R will be neglectable small in relation to L, because L is much larger than R. We can write approximately 1 divided by 4p epsilon 0, 4p epsilon 0, 4p epsilon 0, L, absolute value of Q, absolute value of Q, and the square root L to the power of 2, square root to the power of 3. So in this case, we have this situation. We have this situation. And okay, let's simplify this. Let's simplify this. What can we do with L to the power of 2 under the square root? What can we do in this situation? Okay, we can just simplify this. It will be 1 divided by 4p epsilon 0. 1 divided by 4p epsilon 0. 1 divided by 4p epsilon 0. And here we have L. Multiplied by U divided by absolute value of L to the power of 3. But L is non-negative value. L is non-negative value, so it means that we can rewrite this. We can rewrite this without modulus. Without modulus. So it can be written in this way. It can be written in this way. And finally we will get 1 divided by 4 p epsilon 0, 4 p epsilon 0, absolute value of q divided by L to the power of 2. Divided by L to the power of 2. Okay, do you have any questions about this? Do you have any questions? No questions. No questions. No questions. Okay, if there are no questions, so let's do the last part of this exercise. Define the maximal value of the electric field intensity and corresponding distance that we will assign as Lm. So it is necessary to find such value of L when electric field intensity will be maximal. Okay, and how can we find, according to the calculus, according to the mathematical analysis, how can we find a maximal value of this function? How can we do this? How can we do this? Okay, so to find maximal value, we should find a derivative. We should find derivative and make it equal to 0. When function takes its maximal value, its argument, its derivative is equal to 0. When function is maximal or minimal, its derivative will be equal to 0, or doesn't or will not exist. So derivative of E dE divided by dL divided by dL. Okay, and dL in brackets we have this in brackets. Okay, and who can find Who can calculate this derivative? Who knows calculus well? It is from your first year of education at the university. It is from first year of education. Is a derivative of function with one variable. One variable. Okay. Well, maybe the first step is to write a constant outside of the derivative. So constants are absolute value of charge Q for p epsilon 0, of course, for p epsilon 0, d and dl, d and dl. Here we have L divided by square root of L to the power of 2 plus R to the power of 2. Okay, and how to find to the power of 3, of course. How to find this derivative? No ideas. No ideas. Okay. Okay, I will make the next step. I will make the next step. Oh, it will be absolute value of Q divided by 4 pi epsilon 0. So D and DL. Here we have absolute value of L. No, not absolute value, L in brackets. And here we will have one divided by 1 divided by this square root, and plus L multiplied by derivative ddl and in brackets we'll have this square root. We'll have this relation. Okay, and what to do? The next? What to do? Okay, can you remember? Derivative? Can you remember derivative that looks like this? X. Can you remember this from calculus? No one can remember. No one can remember derivative from x by x, but it will be just one. It will be just one. And so it means that we have 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 here we have just one divided by this plus L. Okay, and what to do with this? What to do with this? Here we have derivative that looks like d by dx, d and dx, 1 divided by square root of x to the power of 3. Okay, and how to find this derivative? Hey, but maybe we can use simple formula x to the power of n derivative. It means d dx x to the power of n, and it will be n multiplied by x to the power of n minus 1. N minus 1. Okay, and what to do in this situation? What to do in this situation? But we can just rewrite this. We can just rewrite this as d by dx. D by dx x to the power of minus 3 seconds. 3 seconds, and it will be minus 3 second x to the power of minus 3 second minus 1 and this will be minus 3 second minus 3 seconds, and x to the power of minus 5 divided by 2, and this will be minus 3 second and 1 divided by square root of x to the power of 5. Okay, do you understand this? Do you understand? Is it clear? Or maybe you have some questions. No questions. No questions. Okay, if there are no questions, let's let's remove this. Let's remove this. Let's remove this. Let's remove this, and we have from here minus it is multiplied by this this square root, uh, but exponent will be 5. Exponent will be 5, and now we have in argument we also have function of L. So we have to multiply this by derivative L to the power of 2 plus R to the power of 2 plus R to the power of 2. Okay, so do you have any questions? No questions. No questions. Okay, if there are no questions, um, I will continue. Doing this. I will continue doing this. Um, so here we will have here we will have such thing, and this derivative will be equal to L. Okay, let's simplify. Let's simplify this relation. Let's simplify this relation. First of all, we will obtain minus 3 L to the power of 2 and close bracket. Okay, we have obtained such relation. And the next step is to make the denominator the same, to find the same denominator. And to do this, it is necessary to notice that that this square root is equal to this the power of 3 and multiplied by this square root to the power of 2. And it will be equal to it will be equal to this square root to the power of 3 multiplied by L to the power of 2 plus R to the power of 2. Okay, and it means that this will be equal to absolute value of Q divided by 4 pi epsilon 0 and L to the power of 2 plus R to the power of 2 minus 3 L to the power of 2 and divided by square root of L to the power of 2 plus R to the power of 2 and to the power of 5 to the power of 5. Okay, and it will be equal after simplifying it will be R to the power of 2 minus double L to the power of 2 and divided by square root plus R to the power of 2 5 5 5. Okay, do you have any questions about calculating of derivative? Do you have any questions? No questions. If there are no questions, such a lot of algebraic transformations. So many transformations we have done here, but we have no choice. In this situation. Okay, and this derivative, in case when E is the maximal value, when E has maximal value, this derivative will be equal to 0. And from here we have obtained equation power of 2m is equal to 0. Okay, and from here we will have that Lm is equal to plus or minus R divided by square root of 2. But L is a distance, and distance cannot be negative, so we have to remove minus. And leave only plus. So it will be this or this. R divided by 2. Okay, do you have any questions about this? No questions. Okay, if there are no questions, If there are no questions, I will just leave this. Okay, and after substitution here instead of L, after substitution, we will get the maximal value of electric field intensity. Maximal value of modulus of electric field intensity. Okay, so the next homework will be exercises number 2, but from electricity and magnetism. Electricity and magnetism. From electricity and magnetism will be exercises number 2 and number 3. And number 3 from electricity and magnetism. It will be the next homework. And it is necessary to remind that I still haven't got any exercise, any homework from you. So I think you should be more active. I think you should be more active. Okay, do you have any questions? No questions. Okay, if there are no questions, thank you for your attention. And I hope to meet you next week.